Hello. So today you'll be knowing what is actual meaning of solubility and what is solubility product, and also how to calculate solubility from those given questions. So here you can see NaCl plus water. So what does this mean actually? So when when sodium chloride plus water react, it gives saturated solution. I'll show you what is saturated solution later. So the outcome is saturated solution. This is, as you know, this is solute and this is solvent, and this is solid state and this is liquid state. So saturated solution means no more solid dissolves. Once it is in saturated, in it becomes into equilibrium state. So you'll get what is saturated solution. So this is saturated. This is these are the differences between unsaturated, saturated, and supersaturated. Here we can see unsaturated solution means more solid dissolves. Means the more solid dissolves means the quantity of NaCl would be more. This is more than water, but in saturated solution, no more solid dissolves. Means like solvent will be less than solute in saturated solution, but in supersaturated crystal may grow. You don't have to remember this, but um, just revising. And this here you see that solute plus solvent gives saturated solution, and once they get saturated solution they stay in equilibrium state. And this is solid. Okay, and so is solubility. So what is solubility? Solubility is the concentration of saturated solution. Like previously we talked, it is the concentration of saturated solution, and also it represents maximum amount of solute that will dissolve. It means that in reaction you have to, like let's say I have barium sulfate, and because it's insoluble, and because they reach the saturated solution very quickly, like quickly, easily. Okay, quickly or easily, you can even say very easily. It gets saturated very easily, very easily. And like that, likewise, here you can see solubility product is the product of the concentration. So if you were asked a question in exam, like what is solubility product? So solubility product, you have to say solubility is the concentration of saturated solution, but solubility product is the product of the concentration of each ion in a saturated solution. Each ion in a saturated solution, like here you can see it's in saturated solution of a sparingly soluble salt at 298 Kelvin, raised to the power of their relative concentration. This you have to like memorize into your mind, that if you were asked what is solubility product, then you have to answer like it is the product of the concentration of ion in a saturated solution, or in a saturated solution of a sparingly soluble salt at 298 Kelvin, raised to the power of their relative concentration. So we have to answer like that. So here is two example. So barium sulfide is sulfate, it gives barium 2 plus, sulfate for minus. It is, this is the ion, and this gets saturated. This gets saturated easily, and this sodium chloride gets saturated very late, slowly. So we have to calculate the solubility product like this, that we do have numerical, you'll get it. So here AgCl, so like Ag silver chloride gives AgCl, so you have to ionize like this if you were given AgCl. And here you will see this Kc. I think you have already studied this, is a equilibrium constant like AgCl, and by this you can arrange this as, so both are constant, Kc and AgCl, and these are the non-constant, and from this you'll get this solubility product. So this is the solubility product, Bi solubility product. And likewise here also, this is the some techniques to remember. If you're given like this and you have to do this, and from this you can do this. So let's do an example. Suppose let me do suppose uh, let's take this barium, let's take this barium sulfate, uh, barium sulfate barium sulfate as Pa2 plus SO4 2 minus. Don't forget to pour this aqueous, and this is solid. And we know that Ksp is Ba2 plus and SO4 2 minus. And what would be the unit? You know that unit of this particular is mole dm times mole dm6 gives mole square for dm6. So do not uh, miss like do not forget to write this unit. It is very important. If you forget to write this unit, then your marks will be deducted. Be careful. So next one example, also I have one. Let's do this. uh, Arrowheads. So what can be written? Like I told you, you have to first separate this, like Fe2 plus 2OH. So this is aqueous, and this is aqueous, and this is solid. So the Ksp would be, so here is the point. Here you can make mistake. A lot of students make mistake here, like they first they do Fe2 plus, and in the second part they just do like this and they missed, but here is 2, so you have to place this 2 here. So if there is something here, then you have to put it here. So let's do calculate its unit. So we have that for Fe2 plus we have mole per dm cube, and for this we have mole per dm cube per square. So from here you get this mole 2, so mole 3, and so 9 is to 6 plus 9, so dm9. So this is the unit of, sorry, this teacher just 6. Okay, it's right, not mistake. So like this you have to do. So again, one example I have, I have one example also. Wait, make sure that you copy this part into your note copy. If you just look this video, then you won't get it, the point. So to get the point, you have to write this in your notebook. So one example also, let's do one final example, like FeOS3. pause this video and try it once by yourself. You try this by yourself. So this is the unit and this is the solubility product. So here, as you can see, a question: uh, a saturated solution of magnesium fluoride MgF2 has a solubility of 1.22 into 10 to the power minus 3 mole per dm cube. Calculate the Classme. So first step, remember, you have to make equilibrium state like this. So this is solid, this is aqueous, and this is aqueous mixture. And in second step, you have to also you can make like this table. I did this so it will be easy for me. So here this A and 0 and 0 initial, no change. And in second, 1.22 into 10 to the power. So why I write like this, because this has a solubility of, so this is the solubility of, so into m it will be as same, and in this here it will be times this solubility. Okay, solubility, like this solubility is 2.44 times 10 to the power minus 3, and equilibrium dash, and this is same and here. And from this you can find Ksp. So Ksp, you know the formula, Mg2 plus times F minus 2. So from this you will get 7.26 into minus 9 mole dm minus 9. I did this because here is some little space. So if you have any question of this related topic, then you can write comment in the comment box. Do not feel hesitate. So to know this, you have to solve a lot of questions. So I'll be also uploading next video about partition coefficient. Just subscribe this YouTube channel, and like the video also. Thank you.